So we're practically at the end of our coverage of the Java Executor framework. We just have a few more things to go through, and we'll start with a more detailed dive into the implementation of the Java Executors utility class. So we'll take a look at some of the key methods that are defined in that class. Just a quick recap. I think you probably know this by now, but just to be complete, the Executors class is a so-called Java utility class. And that's just a way of saying that it's a final class that's not intended to be extended. It only has static methods. It has no non-static state, and it also has a private constructor. And so it's basically just defining a bunch of functions. And these functions are essentially utility methods that are used by various executor framework classes, as well as some factory methods. So the utility methods are things like what I've shown here. They're highlighted in the red box. One example of a common utility method is the default thread factory, which sets the new threads that are created as part of ThreadPool to some known state. And so you can see that by default, it makes a default thread factory that just makes a normal good old thread. There are various methods that use the default thread factory. So newCachedThreadPool that takes no parameters, newFixedThreadPool that just takes the number of threads in the fixed size pool, newCachedThreadPool, which takes the number of threads in the pool. Those are all examples of factory methods that use the default thread factory. You can also make your own thread factory by extending thread factory and then providing an instance of that factory and pass that to other variants of newCachedThreadPool, newFixedThreadPool, newScheduled and so on. And in that case, if you pass in a user-defined or a custom thread factory, then that allows for customization of the threads that are created as part of the pool. So you can have classes that will do things like give the threads special names, give threads special priorities, make them daemon threads versus non-daemon threads, and so on and so forth. By default, they're non-daemon threads, but you can make them into daemon threads if you want to. So these are all the different things that happen using the thread factories that are defined here. There's also a little helper method that is used to take a runnable and turn it into a callable. And you can see there's just something called a runnable adapter, and this implements callable, and it stores a runnable task, and then it has the call hook method in the runnable adapter call the run hook method on the stashed runnable. And so very, very straightforward way of being able to convert back and forth between runnables and callables. The main thing, of course, that's defined in the Executors utility class are the factory methods that make different kinds of executor thread pools. So again, there's a bunch of different kinds of pools. There's a cached or variable size thread pool. There's a fixed size thread pool. There's a work stealing pool. There's a pool that you can create to make a pool of scheduled. It'll have schedules on the basis of time, as we've talked about recently, when you can schedule tasks to run either in a one-shot way or a periodic way, and so on and so forth. So there's a bunch of different ways you can create different types of thread pools. You can also, in fact, if you're so inclined, create a thread pool that just has a single thread in it. And you can either make one that's a single-threaded, just a regular single-threaded thread pool with a little bit of air quotes around pool, or you can also make a single-threaded scheduled executor pool with, again, air quotes around pool. Let's take a look at some of the common methods. These are not the only methods that are provided, but these are the ones that are by far the most common. So let's take a look first at how newFixedThreadPool is actually implemented. And as you can see here, this factory method uses the ThreadPool executor class, which we've talked about before. And if you recall the ThreadPool executor class, it takes a bunch of different parameters. It can take either 5 or 6 parameters. So the first 2 parameters are always the core pool size and the maximum pool size. And for a fixed size thread pool, the core pool size which is the number of threads you always have to have, and the max pool size are defined to be the same, which is the n threads parameter that's passed in to the newFixedThreadPool factory method. It also takes another pair of parameters that give the timeout values. By indicating 0, it says these threads don't ever time out. So the threads that are in the pool, once they're created, stick around, and that's what makes them fixed size thread pool, because they're never changed. Another parameter you give here is a queue, a work queue, which is some type of blocking queue. And what's used here, as you can see, is a linked blocking queue. So it's essentially a shareable, shared, unbounded queue that can keep growing and growing and growing, which is perfectly fine for the default behavior. And then it's also possible to create threads by using a custom thread factory. If you want to make your own thread factory that changes the priorities or changes whether the thread is a daemon thread or not, or gives the thread special names, whatever you want to do, you can perhaps pass in that thread factory. There's also a variant of newFixedThreadPool that just uses the default thread factory and doesn't have a custom behavior. So if you just are happy with the default, go ahead and use the 5-parameter version. Let's take a look now at the cached thread pool. If you recall, the cached thread pool is a variable size thread pool. And the way it works is it will not keep the threads around for very long, past a certain number, if you don't want to, if you don't have them being used within a certain period of time. And let's see how that's actually implemented by taking a look at the implementation of newCachedThreadPool. So as before, we use the threadpool executor to do this. That gets used for a couple of these cases. You can basically, or what it's provided here is it says, I don't want any threads at all to begin with. Just start with 0. And I'm going to put a cap on the number of threads that can be created. And that cap is pretty daggone big. It's essentially integer max value, which is the maximum size of the integer. So you could have, billions of threads. You're unlikely to ever have billions of threads, but at least in theory, you could have them. However, the timeout value here says after a thread is unused for 60 seconds, go ahead and terminate it. So get rid of it, remove it from the pool of threads. However, if a thread has been created and it has been idle for less than 60 seconds and a new request comes in, then that thread can be used to process that request. And the way that that happens under the hood is by using something called a synchronous queue. And a synchronous queue basically does a rendezvous such that it will either pass the request off to a brand new thread, or it'll pass the request off to an existing thread. But it never queues the request. It either makes a new thread or it passes it off to a thread that's currently idle in the pool. And as before, there's a thread factory parameter that you can use if you want to have the cached threads created in some special way. Or if you don't really care, you can just go ahead and use the default behavior. So those are both methods that use threadpool executor. There's yet another factory method that's part of the executor's utility class called newWorkStealingPool. And as the name suggests, it creates a fork join pool. And you can see here the implementation uses one of the fork join pool constructors, and it passes in the target parallelism level, which you can set to whatever you want. You would most likely set it to be the number of cores on the machine. And then it's also got a couple extra parameters here to make the appropriate types of default threads for use with a fork join pool. Those are things that are steeped in low-level implementation details, so we won't go through that in detail here, but just be aware that this creates the appropriate kind of thread for the appropriate threads that are needed for the worker threads in the fork join pool that's being created here.